Okay, I just need to make a quick little announcement before we actually start the video. The specific card that I show here, the mods do all work. And I did do a lot of testing, but once I put it on dry ice, I found that the memory clocked really bad. I mean, I already knew it was clocking bad on relatively low voltage on air, but once I put it on dry ice and tried raising the voltage, it clocked absolutely horrible, couldn't get it above 900 megahertz. And once it got colder, it got even worse to where it couldn't hold 900 megahertz. So I will not actually be doing any serious overclocking with this card. I do have another video planned for it, but yeah, the mods do work for this Dell, the Dell HD 5450s that you can find readily available on eBay. So yeah, here we go. Hey, welcome back to GuardianXOC. So today we're going to be continuing what I hope to become a full-fledged series on this channel where I go over the hard mods and potentially modded BIOSes of hardware that really isn't meant to be overclocked, or at least not to the extent that us as extreme overclockers would like it to be. You may remember in the last episode of this series, we'll call it that for now, we were going over an Asus motherboard, which you hopefully will never have to come across, as it's really not that good for overclocking, but the hard mods did help. So today we are going to be going over this, an AMD HD 5450 that I am pretty certain came out of some old Dell system. Alright, going over the PCB, we'll start with how the configuration would have been with the VRM all stock, so ignoring the mods. Of course, have the GPU core. Right here is the V-Core VRM, and right here is the VMEM VRM. Turning it over, we have the controller for the V-Core right there, and then the controller for the VMEM right there. That's why I have wires going to those. We'll go over to the specifics of those in a bit. But first I want to go over the first mod that I really recommend doing if you're ever modding a card, even if you're controlling voltage through software, and that is some physical read points. So this one right here is for V-Core, and this one right here is for the VMEM. It's the only two voltages I ever really bother modding, especially for a card like this. This card costs $6, so it's not really worth a whole lot of mods. For ground, you just you find some random ground point, but for the live wire, or I should just say the voltage wire, I put those to the outputs of the inductors, and for the most part that's really all I consider necessary for this card. The V-droop is not that bad going from the VRM to the core, or from the VRM to the memory. It's not really a high power draw card, and also it's not really worth it in my opinion to go find some small point to solder onto. These wires that I'm using are pretty big, but cutting connectors off an old power supply is just an easy way to get points that you can put a multimeter probe into. Now going for the voltage mods. First one here is of course V-Core. This is the first one I always like to put on because well, it kind of gets you the biggest benefits quickly, usually, depending on the application, but for this one it was the case. So of course we have one wire just going to ground. The other wire is going to pin 6, I believe. It's the feedback pin of the controller, and the controller for both the V-Core and as well as the one for the VMEM is the APW7165A. It's a very simple controller, doesn't have a lot of fancy features, and it's very easy to mod and get full voltage control of. So the stock resistance between the feedback pin and ground for V-Core was 8.8K, probably it was supposed to be 9K, but that's just from my multimeter reads. And this, I believe, is a 100K potentiometer, and it's not a multi-turn potentiometer, it's just like this spare potentiometer that I pulled off of something a long time ago, and it was just lying around. So it's kind of hard to control the voltage, but I do know that having it at about that angle is about 1.15 volts, and then it goes up pretty fast from there, so you always have to check that before you go starting it. Then the potentiometer I have on the VMEM, it's the same controller, so same kind of idea. I did put an actual multi-turn potentiometer, and this one's actually I think 20 times the stock resistance, which is it's like 5.1K, so I'm pretty sure this is 100K. This might be, I'm not sure. Anyways, it works. That's one thing I know. It's much easier to control the voltage with this potentiometer than it is to control VCore with this potentiometer. Also, you may notice that for VMEM, I did solder the actual pin, I soldered the wire to the actual pin. That's not actually recommended. Because of the package that these have, I consider that kind of okay. And it was actually easier, so that's why I did it, because I did try that for VCore. I soldered it to an actual pad, and it was difficult, but it worked. Also, you probably noticed that all of the solder joints that I have on the card, as far as voltage read points and the voltage control mods, really bad soldering. There's a reason for that. The solder that I was using before was a package of rosin core solder that I actually just bought at Harbor Freight, because it was kind of the fastest way for me to get some solder and get started on electronics. It's 0.8 millimeters. It doesn't have that high of flux amount within the solder, so I don't consider it the best, and it's almost gone now, so don't really need to worry about that. As far as the specifics of each of the individual VRMs, I don't want to bother going over that too much. I'm not actually sure what these MOSFETs are for the VCore, but they are absolutely overkill for the amount of power that the amount of like actual current throughput that I need. Running this at 1.3 volts at a little over 1100 megahertz, these barely got warm. I'm pretty sure the PCB was getting warmer from the actual core than from these. And then on the VCore side, I did bother looking this one up because this single package here is, well, we'll call it a power stage. It's an APM 4906. And that is, it's about the bare minimum you can get for a single phase buck converter. It doesn't have a high side and a low side FET. Instead, it just has the high side FET and a diode, which technically that's all you need for it to be considered a buck converter. But it is capable of a maximum of 6.6 amps total, and that should be more than enough for 4 ICs of DDR3. That's not a whole lot to actually power. So you probably already noticed it, but I also have cap mods on these the voltage rails for VMEM and VCore. So I started off with 2560 microfarad capacitors on both of them, and there was a very nice improvement on the VCore mods. It allowed me to go an extra 60 megahertz, which was really nice. That will definitely be nice for the future. I tried adding a third one onto the VCore rail, and it stopped helping it beyond that point, so I don't know if maybe I just need smaller and lower ESR capacitors on the back of the core to really benefit it anymore, but I'll leave that as it is. VMEM, after getting full voltage control, it's been a little finicky. I think the RAM just isn't that good. It doesn't like high voltage, and so it doesn't scale very well to the voltage you can achieve. And when I added these capacitors, I'm not sure if it made it worse or not. So I'm actually going to be pulling those off at some point and testing it again. But who knows? Maybe they'll work when these are a lower temperature. And of course, a modded card wouldn't be much without any modded cooling. That said, the stock cooler, as you can see right here, is pretty pathetic. But even with these mods and running 1.3 volts on the core, and it was like 1160 megahertz for the actual frequency, it was running at about 70 degrees when under load, which is kind of okay, but we wanted to step it up. So I pulled the cooler off of a GeForce 210 that uses the same mounting dimensions, so it works really nice. It's part of the reason why I bought this GeForce 210 card, was just to take this cooler off. And this works very nice. It was keeping the card at like 40 degrees under full load, just had a fan blowing on it. But my plans for this long term is to take this, cut off this piece here, and cut it off at about here, and then pretty much build a box around this cooler, which can then mount on. It'll be closed on the bottom, but open at the top, and that way it acts as a very kind of cheap dry ice pot for small form factor cards like this. I've been wanting to make something like this for a while, and this is finally giving me the opportunity for it. So yeah, I'll finally be running dry ice on an actual GPU. Alright, so it was kind of important for me to get this video done and out of the way, as I didn't want to try to shoot this video when this was fully prepped for sub-ambient cooling. So yeah, once I'm done with editing this video together, this is probably going to be completely covered in liquid electrical tape, and I'll have the mods finalized so that I can be ready for some dry ice. So yeah, that's about it for the hard mods on this card. Something that I forgot to mention in the main part of this video, as well as not having any footage of it to show you how it's done. This specific card, I'm not sure if it's the same for all 5450s, but this one, out of kind of like, you know, straight onto the test bench, it could only increase the core speed to, I believe, 950 megahertz, and then the memory speed could only go up to 800 megahertz. And of course that's not good enough for us. Like, these volt mods aren't even needed to push it to that. So I had to modify the BIOS, and I used Radeon BIOS Editor, or RBE, as well as WinFlash to get that done. And what you have to do, you have to increase the max power state frequency as high as you can, and that like won't work on stock voltages, so you have to like have it overvolted on the hard mods before you on the system, which, yeah, it has some problems, but yeah, it's something you can work with. And besides, it's not like this card's difficult to replace if I break it. It was $6. But anyways, that's all I've really got for today, and I will see you in the next video. And I do believe this is my 10th video, so I'm going to say please leave a like on it if you liked it. If you didn't like it, dislike it, and let me know in the comments below what you did or didn't like about it. And please feel free to subscribe if you think I'm worth your time. But yeah, see you later.